Hello friends, welcome to our channel. Let's have a look at a newly appeared problem. Find special substring of length key. In this video, we're going to solve this problem by linear scan. So let me write it here. So first, I'm going to introduce some trick, to write the for loop. In other words, I'm going to use some pseudo character, right? So this is actually very similar to if you do linked list, you use some dummy node, same line of thoughts. So, and also what I want to do is first I'm going to write a solution. The time complexity of the solution is going to be O of n, where n is the length of this this S, right? So first I'm going to write a solution. First a solution with space complexity O of n also, and then we want to improve to space complexity to be O of 1. So I hope that you can see the incrementally the procedure. So with that said, let's first look at the problem statement. So here we are given a string s and an integer key. So we want to determine if there exists a substring of length exact key in s, such that it satisfies the following condition. So item 1 basically says that so this substring consists of just one unique letter. The item 2 and 3 basically tell that the substring should be isolated, right? So for example, in example 1, so this AAA or the suffix AA are valid ones. Well, here in example 2, so all of them are actually length 1. So if you consider unique letters, so you return false. So actually, these two examples not very representative in a complete sense. So you can see this example. So you have S equals A, right? Let's see, A equals K equals 3. So in this case, you still do not have, you need to return false. The reason is that though we have 3 consecutive A's, but if you look at each of them, so the afterwards or before, there will be an A. In other words, it either violates the item 2 or violates the item 3, right? That's why we want to count the isolated unique letter blocks. That's the essence, right? Essentially, we do this, right? Count the isolated unique letter blocks. So obviously, this is actually very straightforward to treat. Now let's look at coding. As I mentioned, first I'm going to write a solution with space complexity O of n. In other words, I'm going to build the blocks. So first, let's introduce this n, right? And then I'm going to initialize a blocks list. It's going to store the list. It's a list of list. The list represents a block. So here also, when we write the code, so we want to accumulate the previous letters. So for example, AA, you get 3 A's, but then you have B, so you are going to start a new block, right? So in this case, in order to include the problem logic, I want to introduce some dummy letter, because the letter here involves only lowercase English letter. So I'm going to do this. So for character in S, so append one, just let's see A, right? So this is actually just for for convenience. This is not absolutely necessary, but in order to make the code clean, I will write like this way. So first logic is if not blocks. In other words, we haven't put anything into the block yet, or if the block is not empty, but it's the last block in blocks, that is -1, then the last letter does not equal to the current character. This means that we need to start a new block, right? So then what I want to check is that if blocks and the length of the last blocks equals this key. So we just need to return true, because the current blocks, the current character does not equal to the previous character in the last list in the blocks. So this way of writing guarantees, so no before same letter, no afterwards same letter. In other words, no such cases. So this is the one. So if we delete the, do not consider this if condition. So in this outer if, once we have a different character, we always need to, start a new block. So we are going to append a list consisting current character. That's it. Otherwise, so if the blocks are not empty and we have the last letter in the blocks, it would be the same as the character. So what do we do? So blocks -1 and append this current character. In other words, its length will, same character will be incremented by 1. So that's it. So now you can just return false if nothing has returned after this for loop. So here I want to explain before we run why I add this character. Because if you do not add this character, and then if the last character is different from the previous one in S, then you will start a new block, right? So then you actually didn't check the length of the last block. So hopefully you can realize this dedicated point. So actually it's not hard to understand. So now let me first check this solution. Yeah, it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So now before we move forward, so let me print out those blocks. So here I want to, first comment this out, and then I'm going to print out the blocks. So this is just for aiding understanding. So you can see the first example are going to have A, B, A, right? But we have a pseudo capital letter A, but this does not come into play of comparison, right? So this is the one solution. Now let me comment this out and then come back. Let me first make sure it works. Yeah, now this solution is ON. The reason is that we are making these blocks. So now let me copy this one and improve to be O of 1. So here let me change this. So here, as we mentioned that, so we are not carrying the specific blocks, though in the first version we did some print, we can demonstrate the blocks. But what we actually care about are the size of the isolated consecutive single letter blocks. For example, here is 3, 1, 3, right? So in this example, it will be 1, 1, 1. And okay, yeah, that's all. So now what we want to do, so this we do not change. So now I'm going to introduce a counter variable. So count to be 0. And then a previous variable, previous letter. Let's use another one, which is different from lowercase English letters. So here I can use star, right? Then I'm going to iterate this, but I want to change this a little bit. But in parallel, So first if condition, what we check? So we want to check if the character does not equal to the previous one. And then we need to check the previous count, right? If it equal to key corresponding to here, right? This line. So if count equals key. Notice that key is at least 1, distinguished with this 0. In other words, our logic is correct. So if it were key, so we just need to return true. Otherwise, we need to reset the block. In other words, the previous block corresponding to the counter variable does not satisfy the condition. So now, if we reset that, so then what we want to, so here, I guess, yeah. So we are going to set the previous to be character, but this time we need to reset its count to be 1, not 0, because this does not count 1, but this character currently we are iterating does count 1. But you may think that, oh, I have this capital letter A, but it does not matter due to the way we write the code. So this is the one, and then if this is the if. Let me so otherwise, so if the character equals the previous one, then we just increment the count by 1. So this else actually is why we introduce this capital letter A, right? So this the count incremented by 1 corresponds to here block -1 append a character. Let me delete this part to make the code looks better. So now we just need to return false if nothing has returned. So now let's look at the running, right? So you get true, false, and generic case. Yeah, it passes with 100%. So now you can also do some print if you like, and to see. So for example here, you can print out count. In case 1, once you get 3, so you automatically return. Actually, this is identified. So if we look at the one here, the explanation specified that is AAA, the second one, right? Slightly different. In other words, this solution, if we want to count all, so actually it's not unique, but here what we returned is true or false, right? So as long as we got it, that's it. So for this, you are going to get count equals 0 and 1, 1, 1, right? So you do not have, no one has 2, so return false. So let me delete this one, and then run it again to make it work. So now we finished the coding. So basically, these two solutions are identically same in logic, but in space complexity, they are different. So the first one is O of n, while the second one is O of 1. So overall, for solving this problem, we actually just do a linear scan. And for code cleanness, so we introduce some trick, use some pseudo character or dummy character. So with that said, I guess that's it for the current video. Thank you for watching.